Okay, so let's begin with the question number 3 from the exercise number 1.4. Okay, so let's take the first one. Okay, so when you will see the question number 3, uh, there are 7 to 8 sum. Okay, now in each and every sum, when you will see each and every sum, basically it is based on show that. Okay, so here the first one, it says that x equals to a square root of sec theta minus tan theta, and y equals to a square root of sec theta plus tan theta, and you have to show that dy by dx is equal to y upon minus y upon x. As when you will see in the show that, okay, the sums are very easy. Simply you have to focus on the show that. Okay, so in show that, what exactly we required. So when you will see, when you will focus on show that, here clearly we can see that here we required only y and x, but the given question is in the form of sec tan and a. Okay, but the final answer, our requirement is what? The final answer, it should be in the form of y upon x. So here the first thing is what? You have to try to eliminate this part first, as we don't require this a, sec, tan, even the square root also. Okay, so the first thing is what? We have to eliminate this unknown things. Okay, so as for this sum, there are 2-3 different method, but we're gonna take a very easy and the simplest method, okay, in which you can easily tackle the sums, and in just simply 7 to 8 step you will get the answer. Okay, so as for this sum, there are 3-4 different method, so I will be going to explain, I will be taking the simplest one, okay, out of that 3 to 4 method, which you can understand easily. Okay, so let's begin with the solution now. Okay, so as I told, just simply you have to focus on the show that and try to eliminate the unknown things. As here unknown things for us, it is a square root secant tan. So here what exactly I will do? Okay, just simply focus on the step. So here we know that x equals to a square root of sec theta minus tan theta. Yes or no? Okay, so in the next step, simply I will bring this a down. Okay, just simply focus on this step, what exactly I'm doing. Okay, so now I will give this as equation number 1. And on the other side, here we have y equals to a square root of sec theta plus tan theta. Here also I will bring this a down. Okay, and this part I will give this as equation number 2. And in many videos, in many lecture, I told that always do the adjustment first with the respect to the basic properties. Okay, after that only you derive. Don't start the sum directly with derivative with respect to x. If you feel that we can do some basic adjustment, so first do the basic adjustment and then derive it. As I told in many lectures, doing this thing, what will happen? It will reduce the step as well as confusion. Okay, after this, what exactly I will do? See here, simply I will multiply this equation number 1 and equation number 2. Why you will come to know now. Okay, so here what exactly I'm doing? I'm doing the adjustment. Okay, I'm not doing the derivative with respect to x. So as I know that, okay, to reduce the step, to reduce confusion, so first we'll do the adjustment, all the adjustment with the basic properties. Okay, and then after that we'll derive it. So here I know that using this all things, I can reduce the step. Okay, so as I told, this is not only the method in which you can find your answer. There are 2-3 different methods. Okay, but I feel that this is the easiest method which I can explain and you all can understand easily. Okay, so after this, what exactly I will do, I will multiply this equation number 1 and equation number 2. So we'll multiply the left hand side and equal to then the right hand side. Here we have sec theta minus tan theta into square root sec theta plus tan theta. So after this, x into y, here you will get xy upon a into a, here you will get a square equals to, here the square roots are same. Okay, and clearly we can see that this look like this, a minus b into a plus b. Okay, so can I write this step as in the next step as square root of a square minus b square? Okay, so here we can multiply this a minus b and a plus b. So here you will get a square minus b square under the root. Yes or no? So here you will get what? Square root of sec square theta minus tan square theta. Yes or no? Okay, so therefore x upon y, x into y upon a square equals to, as we know that using the identities, in place of sec square theta minus tan square theta, I can write 1. Yes or no? So here I will write 1. Okay, so therefore xy upon a square equal to square root of 1 is what? 1. So here we left with xy equals to, we'll shift this a square to the right hand side. So here you will get xy equals to a square. So here I can say this is the adjustment part. So I had reduced the step. Okay, so as I told, just simply you have to focus on show that, and whatever the unknown things are there, try to eliminate that part. Okay, so here I had eliminate the square root as well as second tan. So here we left with the a square part, a part. Okay, so now we'll try to eliminate this a also. Okay, so as now I guess we did the adjustment part. So after this, I cannot see any further adjustment. So here after this, we'll start with derivative with respect to x. So therefore, here clearly we can see that here we have xy. Okay, clearly we can see that here we have xy, and the connection between this is multiplication. So we know that whenever there is a connection between two terms, there is a multiplication. So we have to use u into v rule. Yes or no? Okay, as clearly we can see that here we have x y equals to a square, as the connection is multiplication. Okay, so here this part will take as u and the second part will take as v, and we have to find the derivative with respect to x. Okay, we have to find the derivative with respect to x. Okay, so here for this part, okay, except x and y, the remaining 24 alphabet you have to consider as a constant. So here a will be what? A constant. Okay, so here we'll use the u into v rule. So here you will get u into derivative of v, so this will be dy by dx. Okay, plus v into derivative of u, so derivative of x is what? 1, and a square is constant, so it will be what? 0. So therefore x into dy by dx plus y equals to 0. So therefore x into dy by dx will shift this plus y to the right hand side. So here we will get minus y. Okay, so after this, dy by dx will keep as it is. Now we'll shift this x down. Okay, so here we got the final answer. Okay, so that is dy by dx equals to y by x. Okay, so as I told, the sums are very simple. For each and every sum, there are 2 3-4 different methods. Okay, so it is on you which method you will pick up and you will present your sum in the board exam. Okay, so out of that 3-4 method, I felt this one will be the easiest method which I can explain, I can express myself, and you all can easily pick up the steps. Okay, so out of that 3-4 method, I felt this one is the easiest method. Okay, so the technique for this types of sum, it is very simple. Just simply you have to focus on show that, just see the show that, and then check out the given. Whatever the unknown terms are there, try to eliminate that unknown terms. That's it. Okay, and always do the adjustment first with respect to the basic properties, and after that only go ahead with derivative with respect to x. Don't start any sum directly, derivative with respect to x. Okay, if you feel that we can do some little adjustment, then go ahead with the process, and then after that only you do the derivative with respect to x. So this was the question number 1. I hope you all understood the procedure. Okay, like how to frame, how to present our sum, and how to find a final answer. Okay, and see to it that you have to mention all the properties, all the formulas on the right hand side as a reason. So whatever the properties, what is the formula you will be using for that particular question, on the right hand side you have to mention that. Okay, so let's move on to the second question now. Okay, so now in the second question here we have x equals to e raised to sine 3t and y equals to e raised to cos 3t, and then you have to show that dy by dx equals to y upon x log x upon log y. As I told, the fundamental, it is very simple. Just simply you have to focus on the show that. As in the show that, clearly we can see that here we have log, but in the given section we cannot see anywhere log. So anyhow we have to attach log, or by using some properties we have to bring log somewhere, because as clearly we can see that in the show that we required log. Okay, to bring log or to attach log, there are two methods. First, taking log on both the side. Okay, so you can just take log on both the sides, so you can attach log. Okay, or else using this property, okay, logarithm property, log b to the base a equals to x. Okay, and we know that when you will do the exponential form, so here you will get a raised to x equals to b. So as clearly we can see that this pattern look like what? A raised to x equal to b. So we can convert this a raised to x equal to b in the logarithm form, so where you will get log. Okay, so this is one method. Or else the simplest method I will say to bring log is what? Just take log on both the side, that's it. Okay, so here we'll start with the solution. Again, for this sum also there are 2-3 different method. Okay, so of course we're gonna see the simplest and the easiest method. So here we'll start with the solution. So here the first part is what? X equals to e raised to sine 3t. Okay, so first step we'll do taking log on both side. Same thing here also we'll do for y equals to e raised to cos 3t, because in the given section clearly we can see that here we required log. Okay, in the given in the show that, but in the given the log, it is not there. So as I told, the unknown things we have to remove, or suppose unknown things it is not there, so we have to attach that unknown things also. Okay, so here we required log. So the simplest method is what? To bring log or to attach log is what? Taking log on both side, or else clearly we can see that this part look like exponential form, a raised to x equals to b. So we can convert this a raised to x equal to b in a logarithm form. So in that case also you will get the same answer. Okay, so after this we'll take log on both the sides. So log x equals to log e raised to sine 3t. So therefore log x equals to, so this sine 3t will come down. Okay, sine 3t will come down into log e by using the property log a raised to m. Okay, m will come down. Okay, so like that sine 3t will come down using this property. So after this, log x equals to sine 3t. As we know that in place of log e, we can write it as 1. So when you will replace this log e by 1, so sine 3t into 1, you will get sine 3t only. Okay, so this is the procedure. Okay, so as I told, first we'll do the adjustment and then after that we'll derivate. Okay, so after this, I guess we cannot do any further adjustment with respect to any properties or with respect to properties of log. So after this we can derivate. Okay, so we have to derivate here, derivative with respect to what? Okay, as here clearly we can see that on the right hand side here the alphabet is what? T. On the right hand side the alphabet is what? T. Okay, so here we have two different function. Okay, two different function, and on the right hand side clearly we can see that alphabet is T, so the parameter is T. So with respect to T, you will find the derivative. Okay, so here if you will find the derivative with respect to T, so here x and T, except x and T, the remaining 24 alphabet you have to consider as a constant. Okay, so in the next step, this log x will be what? Okay, as we are finding the derivative with respect to T, so respect to T means log T, we know that it will be 1 upon T. So log x will be what? As here we have to find the derivative with respect to T, so log x will be 1 upon x, but T is replaced by x, so we have to use the chain rule also. Okay, because here we are finding derivative with respect to T. Understood? Okay, so here T will act as what? X. So this will be what? 1 upon x. This will be what? 1 upon x into dx upon dt equals to sine 3t. Sine 3t. So we know that derivative of sine 3t. Okay, derivative of sine 3t. Derivative of sine is what? Derivative of sine t will be what? As we are finding derivative with respect to t, so t here t will act as x, yes or no? So derivative of sine will be what? Cos t. So here it will be what? Sine 3t. As here clearly we can see that t is replaced by some other term. So whenever you see if it is replaced by some other term, you have to use the chain rule concept, yes or no? So here we have to find the chain rule of, we have to find the derivative of that 3t also. So here first we'll find the derivative of sine 3t. So sine 3t will be what? Cos 3t, but here x is means t is replaced by some other term. Okay, so what is that some other term? It is 3t. So after this, 1 upon x into dx upon dt equals to cos 3t into, now we have to find the derivative of 3t, derivative of 3t. So clearly we can see that 3 is constant. So as we know that whenever there is a constant and it is attached to any function, keep the constant as it is and simply find the derivative of the neighborhood term. So here t, derivative of t will be what? 1. So here derivative of 3t will be what? 3. Okay, done. So I hope you all understood till here as I'm explaining each and every step clearly. Okay, so still if you have any doubts, so please let me know. Okay, so after this, what exactly I will do, I will keep this dx upon dt as it is, and I will shift this x to the right hand side. So here you will get what? 3x into cos 3t. Okay. So here we got the answer for dx upon dt. Okay, so now here we'll use the same concept, same fundamental to find dy upon dt. So taking log on both the sides, so here you will get log y equals to log e raised to cos 3t. Okay, so therefore log y equals to this cos 3t will come down. Okay, using the property log a raised to m equals to m into log a. Yes or no? Okay, so after this, log y equals to cos 3t. We know that log e value is what? 1. So in place of log e, we can write 1. So cos 3t into 1 will be what? Cos 3t. Okay, so as that adjustment is over, so now we can find the derivative with respect to x. Sorry, with respect to t as the parameter. On the right hand side, clearly we can see that it is t. Okay, so as we are finding derivative with respect to t, so here the answer for log y will be what? We know that derivative of log t with respect to t will be what? 1 upon t. But for log y, it will be 1 upon y, but here t is replaced by some other term, so we have to find the derivative of that part also. Yes or no? Okay, so here log y derivative will be what? 1 upon y into dy by dt. Understood? So you will write 1 upon y into dy by dt equals to, so now we have to find the derivative of cos 3t. So derivative of cos 3t will be what? Minus sine 3t, but here t is replaced by some other term, because we know that we have to find the derivative. We know that we have to find the derivative of cos 3t. Okay, but we don't have the derivative of cos 3t, we have the derivative of cos t only. So derivative of cos t is minus sine t. So here clearly we can see that t is replaced by some other term. Okay, so we have to find the derivative of that part also. So here in the next step, this will be minus sine 3t into 3t derivative. Just now only we saw the answer is 3. Okay, so 1 upon y into dy by dx. So after this, simply dy by dt. Okay, so after this, we'll keep this dy by dt as it is. We'll shift this y to the right hand side. So this, in the next step, you will get what? Minus 3y into sine 3t. Okay, so here we got the answer dy by dt. Okay, so as we required the answer for dy by dx, okay, so simply we'll divide this two section to get the final answer. Okay, so when you will divide dy by dt dx upon dt, so there you will get dy upon dx, yes or no? So dy by dt is what? Minus 3y into sine 3t. And what about dx upon dt? It is minus, sorry, for dx upon dt is what? That is 3x into cos 3t. Okay, so here we can cancel out 3. So here we're left with what? A minus y upon x. Okay, but in place of sine t3, we required here log x. Yes or no? In place of sine 3t, we required log x. And in place of log y, Means in place of cos 3t, here we required log y. Okay, now here just simply focus on this section, this part. Okay, this part will give this part as equation number 1 and this part as equation number 2. Why? I will explain. As clearly we can see that here sine 3t is what? Log x. Note. And here cos 3t is what? Log y. So we'll give this part as equation number 1 and equation number 2. So directly in place of sine 3t, we'll write log x, and in place of cos 3t, we'll write log y. And here we'll mention that here we got the answer from 1 and 2. So here we got the answer, that is dy by dx is equals to minus y into log x minus y log x upon x into log y. So here it is proved. Okay, so in this way you can present your sum. Okay, now this is not only the method. There are, as I told, there are 2-3 different methods in which you can find your answer. Okay, so this, I guess it is a safer and the easiest method. Just simply what you have to do, just check log on both the side. As a complete one exercise we did based on taking log on both the exercise, both the side. Okay, so yes or no? So basically it is exercise number, I guess exercise number 1.3. okay, so all and sole sum, it was based on the taking log on both the sides. So many sums we did with respect to that. So just simply take log on both the side and then do the adjustment with respect to log property, derivate with respect to the parameter which is there on the right hand side. Okay, so where here you will get dx upon dt. Okay, so here you will get dx upon dt. After that, simply you find dy by dt. Okay, so as per the parametric form, we know that we have to divide dy upon dx. Okay, so dy upon dt divided by dx upon dt. So where you will get dy upon dx. So after that, here we got the second last step. So where we saw we don't want the sine 3t and cos 3t. So when we saw here already we have the value sine 3t is equals to log x and cos 3t is equals to log y. So here I had given this part as equation number 1, equation number 2. Just simply mention here from 1 and 2, I had replaced the value of sine 3t by log x and cos 3t by log y. So in this way, you can present your sum. So this is what you have to do. So the sums, as I told, it is not that much complex. Just simply you have to focus on show that, and check out if there are unknown terms, try to eliminate that unknown terms. And suppose if we require that section, just simply you have to do such a basic adjustment in a such a way that you will get that section easily. As here for the second sum, for the first sum, what we saw, we don't want this a sec theta tan theta square root. Okay, so here what I did, I had eliminated the unknown part. But in the second sum, clearly we saw that we required the log. Okay, so sometime what will happen, you have to eliminate the things, and sometime what will happen, you have to do the adjustment, you have to attach that unknown things. Okay, so these are the things which you have to do for the question number 3. The sums are very simple, just I told, just simply focus on the show that. Okay, so if the unknown terms are there, if you don't want, remove that unknown terms. If you want, just simply attach that unknown terms. Okay, so this all things you have to do for the question number 3 of exercise number 1.4. okay, so let's move on to the next sum. Now I hope you all understood the first and second sum. As I told, there are 7 to 8 sum in the question number 3. Each and every sum, it has own format. Okay, because when you will see each and every sum, we will be dealing with some different concept. Okay, as I told, for each and every sum there are 2-3 different method. Okay, so just don't stick with one method only. Okay, so out of that 3-4 method, whatever the method you feel easy, so just simply apply that better in the board exam to get the answer. Okay, I'm not saying just simply you have to stick this method only what I am teaching. Okay, if you feel that there are some other method also, so you can do that in the board exam. Okay, so let's move on to the next question, that is question number 3.